Hello again. Just continuing with talking about valuing equity as a call option on the value of a firm. It's interesting to compare the normal way of doing the valuation of equity as with discounted cash flow versus valuing equity as a call option on the value of the firm. This is the normal way, right? You value the firm as the present value of all future cash flows, right? Every cash flow at T using the weighted average cost of capital as the discount rate. And then you go E is equal to V minus D. Of course, there's other ways that, you can describe in another class. But this is sort of the general way it goes. And it's interesting, when you value equity as a call option, you actually also need to get V this way as well, right? Because you need to have the value of the underlying asset as one of the inputs to the Black-Scholes. So we could stumble into some form of circular logic here, and we probably will. But in any case, when you look at discounted cash flow valuation, volatility raises the WACC, and that lowers V, right? If you discount by a higher rate, you're lowering V, and that would lower E, right? Lower V minus D is lower E. Volatility is kind of an important difference point between the two ways of valuing equity. Volatility hurts wealth when you look at it as discounted cash flow, but potentially increases shareholder wealth when you think of equity as a call option. It's well known to those that do uh, involve themselves with financial options that the value of a call generally goes up with the volatility of the underlying asset. I mean, think about a call option on something that's deep out of the money and has very little volatility. Well, there's not going to be much time value because it's pretty likely that since it doesn't move much, it's not going to move into the money before expiration. But if on the other hand you had a underlying asset that was deep out of the money but highly volatile, then there'd be much more likelihood that it could bounce into the money before expiration and so on. So the two conflicting effects, this effect is sort of similar to what we described before. The volatility of the underlying asset lowers V, and so the value of a call goes down with a decline in the value of the underlying asset. So on the one hand, volatility lowers the call by impacting the underlying asset. On the other hand, volatility raises the value of the call by impacting volatility, which is an input in the Black-Scholes. Generally speaking, this second factor, the one that increases value, is seen as the dominant factor in financial options, right? It is interesting, right? If you're considering giving out employee stock options as incentives, are you also incentivizing greater risk taking and so on, right? Well, let's look at an example of a really simple example of like modeling a merger. We're going to have two firms and A and B. And what we're going to see when we calculate the volatility of the combined firm is the volatility will go down just a little bit. It'll go down to like 39%. And so that will actually cause the value of the equity of the combined firm to be less than the value of the equity of the two firms summed together. But the thing is that when we use the new volatility of 39%, we didn't adjust the 100 and the 150. So we're a little bit skewed here. So to get the volatility of the combined firm, we use the formula for the volatility of a two-asset portfolio. And you might recall that from previous lectures and so on. And this is our volatility of the combined firm. And then we would have all the inputs now to do the Black-Scholes on A, B, and the combined. So we have to do the Black-Scholes 3 times, and I don't do it here, but I would really think it would be a great idea if you could do that at home and see if you get the same answers. And you get that A has this equity, B, but the combined equity is not A plus B. That would be 210.41. Oops, I'm messing things up here.